guess. All right. Okay, class. Good to see you today. Beautiful day today. Sun is out, shining. Things are warming up. So anyway, I hope you had a good weekend. And I had a busy weekend, but it's good to shift gears and be busy here instead of at home for a change. So last time we met, we began chapter 14. And we talked, some there about how an economist measures profit as opposed to how an accountant does, okay? That is to say, there's a difference between economic profit and accounting profit. Economists sometimes have a broader view of what are entailed in cost, in the cost calculation, okay? So consequently, because economists factor in implicit cost, opportunity cost, and so forth, which include implicit cost, then by an economist's calculation of profit, profit's smaller, okay? So we did this calculation last time. We'll be coming back to that, but please go back and look at that, all right? If, you don't understand what economic profit is and why it's smaller than accounting profit, that's where we left off last time. I will just say, and I don't have that example, I don't believe, didn't bring it with me that we marked up last time, but we noted that a positive economic profit, however small, a positive economic profit's a good thing. So if you tell somebody, or if you hear somebody say, hey, my profit last year was $10, okay, most people would say, what? That's terrible. In your business, you had a $10 profit. But if they're an economist telling you this, then they're telling you about economic profit. And really what they're saying is that they did better last year by $10 than they would have in their second best alternative. That's kind of a way of looking at it. So any positive economic profit, however small, is a good thing, okay? It basically says you're doing better in that enterprise than you would have otherwise in some other enterprise. So remember the example we looked at, people who worked at the post office, okay? And some were looking at going into the landscaping business, and they did so, and their profit was kind of a small number. Well, that's a good thing. That means they're doing better in the new enterprise than in their previous line of work. So we'll be coming back to that, but we'll be noting that if you have a positive economic profit, that's a signal to potential entrance in an industry, potential entrance in an industry. We're going to come back to this when we look at market structure, particularly perfect competition. Next time, we're in perfect competition. You have free entry and exit of businesses in an industry. We'll talk about that. And as long as that economic profit's positive, you have new entrants, okay? There's no barriers to entry. You have new people flocking into that industry. So in that example, just to put this to rest for the moment, we'll come back, but you're going to have people leaving their jobs at the post office to go into landscaping so long as there is a positive economic profit, however small, okay? It turns out as you have more of that movement of resources from one industry to another, in that industry that's receiving inputs, increasing inputs, then economic profits shrink, okay? We'd see that. If more people quit their job at the post office, go into landscaping, guess what? The average profit for a landscaper in a small town is going to go down. Okay, and as that profit shrinks, talking economic profit, as that profit shrinks to zero, then the spigot gets turned off, okay? There are fewer entrants. At any rate, that's a preview of some things. I wanted to mention that here because we're going to revisit that topic in the next chapter. And so if some of that sounds like a riddle to you because you haven't looked at that since last time, that's okay. But you certainly want to go back and study on that, think on economic profit before we get to chapter 15. Okay, but we're not to 15 yet. We're in chapter 14. And so in chapter 14, we begin the last unit of the course, unit 3, and in particular we're going to talk about production, okay? Production. So last time we introduced chapter 14 again with calculating costs, various types, implicit and explicit costs, and how they contribute to what's called economic profit. So set that to the side for a moment. Today there's a fair amount of detail in section 14.2 of your text, and it could be that we'll spend all of our time on this one section today because there's a lot of interrelated concepts here. Driving in this morning, I thought, okay, it's been a little while since I've taught this material, and you kind of get a little rusty on it, but at one time in my career I taught this a fair amount, and I know there's an order of topics, okay, an order of concepts here you kind of have to weave your way through to kind of get a good picture when you start talking about cost of production. So driving in, I was thinking about this, and so I want to kind of have kind of an outline in my head. Let's see how it goes, okay? So we're going to talk about how much does it cost to produce things. And in this section, it's very critical to note, we're looking at what's called the short run, okay, not the long run. In the next section, which is 14.3, well, I guess it's not 14.3, it'll be, because we're going to do two sections here, so it'll be 14.4. We'll look at the long run. And they say, what's the difference here? Okay, in the short run, there is a fixed input. Okay, that's how economists define the short run. Okay, it's not 6 months necessarily, it's not a year, it's not 30 days, it's not 2 years. Economists define the short run this way. For someone who produces things, a manufacturer, we'll look at a manufacturing context here today. The short run is a length of time in which the owner, say, the manufacturer, has to live with at least one fixed input. There's something they can't change. Okay? So you can imagine here for a moment, if we have a little factory, and there's 20 of us here or something here today. So we have a little factory, and we each have a little workstation we work at, and we produce chairs. There's a chair right there, so say wooden chairs. We produce wooden chairs, and we may get new contracts for chairs and this and that, maybe a special kind of chair, so forth. So at any rate, week by week, we look at our contracts, and maybe I'm the business owner just because I'm up here, so say, hey, we got a lot more chairs to make this week. I need to go out and hire some more workers. So I might be able to hire and, hate to use the word, but fire workers as I need to produce a number of chairs that are in demand for that particular week. I'm operating in the short run. You see, what I cannot do is this. I cannot expand the size of my factory on a week-to-week basis, okay? Or even a month-to-month or perhaps a year-to-year basis. It may take 10 years. If I say, hey, my chairs are really popular, it may take 10 years for me to raise the capital as a business owner to expand the floor space in my factory. Which is to say, then, there is a fixed input to production in that situation, in that environment. I can't change the floor space in my factory. Okay, so just some concepts. Let's look at some concepts here. Just nothing too abstract here. But I want us to think about some things before we get into this chapter. Give you a little background I think perhaps our author could have given us a little bit more on. But short run, that's our focus today. So today we're going to look at what are called short run cost functions. Okay, short run cost functions. That's our topic for today. So we're in the short run. So in other words, it's something we can't adjust. So here's our floor space. It's rectangular here. And we have workstations here. Maybe they do different things. And I'm not going to draw too many of these. Okay, already drew more than I. But maybe you got, you make these chairs. So you got raw lumber come in, certain kind of wood, raw wood come in from one door. And so maybe you got a chop saw, you know, and you got a lathe, okay, and you got a finisher. You get the drift. And you got these different workstations. You maybe have 2 chop saws and so forth. And over here, maybe you got, you know, someone who mans the office or something, but you got packaging over here, or wrapping, and so forth. Okay. So it's a factory, has a limited floor space. Week to week, you're the manager, you want to fill orders. Orders go up, orders go down week to week. You're operating in the short run because you can't change the size of this factory. Now, you might be able to buy more machines, okay? You might be able to pack more machines in here, but there's something, just by definition of the short run, there's something you can't change here. And it seems logical to me here that the stickiest thing, if you will, the thing that's hardest to change would be the floor space. In another situation, the floor space might be easy. You might operate your factory in a vacant mall somewhere, and you can, yeah, we can pull in more floor space, no big deal. But you know, getting those machines, that's hard to do. I got to go out and raise a lot of money to get another machine. Again, you'd be working in the short run. You'd be making decisions, output decisions in the short run. Say if you wanted to increase output, you'd have to have another machine. But you know, if it's the machines that's the hardest thing to procure, then you know, it's the machine time, the delivery time to get a machine, or acquisition time, I guess I should say, that's going to define the short run from the long run. Okay, it takes a long time to get a machine. Okay, so whatever it is you got to live with will define the short run. So I'm going to just say floor space here for a minute here. And suppose we make these chairs, okay? And you know, you got these different stations down. Now here's one way. If you didn't have very many chairs to make, and you're the owner, you may say, I'm just going to hire one worker, okay? One worker. So one worker chops the raw lumber, and then they go over. They got to make the legs, so they use the lathe a little bit, and then finisher. And so what you'd see is you got a jack of many trades here, moving from one workstation to the next, okay? And so, you know, one worker can output quite a bit, but if you had, say, I want to increase my output, and instead of working this person harder, what you might do is hire a second worker, okay? So you hire a second worker, well, yeah, but guess what you begin to do? You begin to take advantage of specialization, okay? In that this worker can just get really good at these 3 machines, this worker can get really good at these machines, and so forth, okay? So what you see is that we can increase output here in a rather efficient way by taking advantage of specialization, okay? If we wanted to double output here, we could double our number of workers. And so the next week, we could take advantage of more specialization. Okay? So this first fact here, if you will, maybe it seems obvious, but it's going to have a profound impact on how we sketch cost curves in a moment, is that at low levels of production, we can take advantage of specialization. Okay, now what does that mean? Okay, essentially that means if I double my number of workers, I'll more than double my output, really. Okay, if, you know, every time I add a worker, I get more output, but 2 workers, if I go from 1 to 2, 2 workers, going to more than double what 1 worker can do. Why? Because they're specializing, okay? So if you're able to specialize, wow, okay, 2 can do more than twice what 1 can do. 4 will do more than twice what 2 can do. Does that make sense? As long as you can specialize. So we have our output here. Our output kind of grows, if you will, kind of in an exponential fashion. As we pack more workers in, you add more workers because you want more output, okay? So you add more workers and so forth, you get more output. Now guess what? If I want to double my output again, 1, 2, 3, 4, I guess I could have 8 workers in here. It could be a little silly. And I guess that's about where I am here. I don't know if I counted right. There's 8 workers. Wow. Everyone is assigned to their own machine. Are you going to get good at that machine? You bet you are. That person, that's all they do is use that saw. Man, boom, 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 boom. So you double, okay, the number of workers. That is to say, you're still renting the same factory here. You're still renting the same number of machines. So there's nothing being done here about fixed cost. Fixed cost. Let me just write that term here to the side for a minute. That's like rent and so forth, the rental, machine rental, floor space rental. You're not doing anything there. We set that to the side, but we do when we go from 4 workers to 8 workers. We do double our variable cost. Variable cost, okay? Just to note these terms here, we'll be coming back to. So the variable cost, when we go from 4 workers to 8 workers, it's going to double. Because our only variable costs here, well, you got lumber. Don't worry about that too much for a minute. But you got labor, okay? So you got 8 workers instead of 4, you doubled your variable cost. Okay. All right. So just some things to note here. But at low levels of production, you have what we might call increasing marginal product. Okay? Increasing marginal product. Increasing marginal product. MP, marginal product. Okay, what are we talking about there? We're saying that because of specialization, when you add an additional worker, that worker is going to deliver a proportionately higher output than the one before. The second worker delivers more than the first worker did when he was working alone. The first worker made 10 chairs in a week. Yeah, the second worker, and guess what? The first worker now is going to make more than 10 chairs in a week, and so is the second worker. Why? Because they specialize. Okay, does that make sense? You have increasing marginal product. That is to say marginal, which means the additional. Marginal means additional. You have increasing output for each additional input unit of input. In this case, just keeping things simple, the unit of input is a worker. The second worker increases output by more than hiring that first worker did. So the first worker made 10 chairs. Second worker is because they're going to help the first worker be more productive. Second worker is going to produce maybe 12 chairs in a week. In fact, both of them will. Okay? So you more than doubled your output. You went from 10 to 24 by doubling your input, number of workers. Does that make sense? That's called increasing marginal product. Okay? Now we could sketch what's called a production function here, and we will in a minute. Actually, I robbed one of these out of a book. Let me just say here for a moment. I won't say what book I robbed this from, but they don't have this in your book. This is called a total product curve. This particular shape here, it says TP. This particular shape is ubiquitous. It's in manufacturing, so many places. That is to say, when you start moving from quantity of labor, notice here quantity of labor on the horizontal axis, when you go from 1 to 2 workers, you more than double the output. If you doubled the output, then you would simply be moving along a straight line. Okay? The slope would be 2. Okay, so in other words, output for 2 workers would be twice output for 1 worker. But no, in the early part of production, so you might want to kind of sketch a curve like this. We got quantity of labor on the horizontal axis, and you got output, okay? Output, just write output if you want, on the vertical axis, and it's got this shape, okay? I'll draw it here in a minute. For low levels of output, because of specialization, it's going to be convex. It's going to go up like this. However now, we're in the short run, so if we say, okay, next week, instead of making this many chairs, let's double this. Okay, where's my picture? So let's double this. Well, obviously what's going to happen is you bump up against a constraint, don't you? So if you have 8 workers here and there's 9 workstations, and you say, well, let's double our output, so let's go out, let's try hiring 16 workers. Guess what? You get workers who aren't as productive, right? Because they're waiting to use a machine, okay? Now, this won't happen in the long run, but you're going to observe something called decreasing marginal product at high levels, okay? High levels of production. What do we have here? Instead of specialization, you have crowding that takes place. And because of crowding, you have what's called decreasing marginal product. Now, what am I saying there by decreasing marginal product? Okay. Now up here, when I say increasing output for each additional unit of input, not only am we increasing output, but we're doing so at an increasing rate. Okay? All right? We're increasing output for each additional unit of output at, so let me insert this here if I can, at an additional rate. So, I mean, it's true 8 workers gave us more than 4, but we got a bigger kick with the second 4 workers than we did with the first 4 workers. Okay? So this is important you say this, at an additional rate. Okay? It's kind of like you're in your car and you can speed up if you want. But you can speed up at an increasing rate. That's called acceleration. Okay? That's when it puts you back in your seat. Okay? That's when it really pushes you back. So without getting into any of that differential calculus and so forth, let me just say you can increase at a decreasing rate, increase at an increasing rate. Throw a ball up in the air. After the first second, it's still going up. The height is increasing, but at a decreasing rate. Okay, it's going up, but slowing down. Okay, here it's growing up, but it's going up, but it's like a rocket, man. It's increasing at an increasing rate. Now I'm going to talk about this stage of production when we begin to bump against this constraint at high levels of production. Because of crowding, you have decreasing marginal product, or as your book will call it, and this is a term everybody uses, diminishing marginal product. When you say decreasing, usually you hear the word diminishing. Diminishing marginal product. Okay, what are we saying there? We're saying that, yeah, with 16 workers, you might get more than you did with 8 workers, but most of them, some of them are going to be in the break room all the time, because they're going to be in someone's way. In other words, you can push output higher by increasing your input, but you'll increase output at a decreasing rate. So I will write the same thing here, but I'll just replace this word here. Here, with diminishing marginal product, we can increase output for each additional unit of input, but at a decreasing rate. Okay, does that make sense? Let me just sketch it here, just kind of shorthand. We can increase output for each unit, for each additional, for each additional unit of input. I could have typed this out, I guess, at a decreasing rate. Hopefully you can, since I'm reading it as I'm writing. Whoa, here we go. All right, so we can increase output for each additional unit of input, but at a decreasing rate. So I want to go back to this curve, then I'm going to show you the one that's in your book. So on a total product curve, you're still going up as you add additional units of the variable input, which in this case units of labor hours in a week or something like that, but you're increasing at a decreasing rate. The ball's still going up in the air, but it's slowing down, okay? So here it's got a rocket on it, but here it's slowing down. Does that make sense? Now, of course, at some point here, you can pack so many workers in this factory that they can't hardly move, okay? And then you get to this part of the total product curve, which is not really relevant for what we're going to be doing in this course, but for our problems. But I do want you to know about this part of what's called a total product curve. So I want to just give you a rough sketch of one, okay? Total product curve is, you could look at number of workers hired, okay? Number of workers hired, which is workers on the horizontal axis. Workers. And we can talk here about the total cost of workers, but here first we're going to look at their total product here. It's going to look like this, okay? Kind of a backwards S-shaped curve, just as I was looking at there. There's two parts to this. There's the low levels of output, where when you increase workers from 1, 2, 3, and so forth, you're increasing output at an increasing rate. So increasing output, which we'll say Q, at increasing rate. Maybe that's up to the fourth worker, I don't know. But beyond the fourth worker, we can add a fifth worker and still increase output, but now at a decreasing rate. We get a little less bang for our buck. We still get bang for another worker, but they're adding a smaller additional output than the previous worker did. Okay, so here we have increasing output, Q, at a decreasing rate. Does that make sense? So here you got Q for output here. Just say Q for output. Okay. L for labor, if you will. Okay, so this is called a total product curve. Now, it looks a little different than the one they give you in your book. Okay? I'm giving you because I don't want to take too much issue with the great Greg Mankiw. He's really a great author. He's a greater economist than I'll ever dream of being. But a lot of times in a principles level course, you'll see more of the production function, or also called total product curve. They're the same thing, a production function in the short run. Then just this part here, he's included this part here, okay, this part here, in that picture. But there is a specialization that happens before this part kicks in here. That is when we say increasing output at a decreasing rate. That's a phenomenon we want to take special note of here. This is called, it's a law, it always happens. This may or may not happen, by the way. I mean, usually you have specialization, but, you know, maybe not. You know, those machines may not require much training. You know, that chop saw, that lathe and all that. You just put someone on. There's not much kick to having specialization. You can imagine a work environment that way. But you always get into that crowding out effect when you start trying to push output or the number of workers in a short-term context. So this one law always kicks in the short run when you start increasing output. It's called the law of diminishing marginal product, okay? Diminishing marginal product. The product of the marginal unit of labor, say the fifth worker, delivers less additional output than the one before. That's always going to happen. At some point, this kicks in, okay? And that's what your author, and your author's taken a very economical way of presenting this topic here of production in the short run today, and so I understand his approach. It's okay, but for the problems, but I do know where we're going, and I think for us, it's important for us to note that the total product curve, or production function, generally has an S shape to it. But for what he's going to talk about here, in the body of this chapter, for sure we need to focus on this. This is a result of, well, what's the condition that drives diminishing marginal product? It's because we're in the short run. See, it's in the short run, you can't change the size of that factory floor. Now, if you could expand everything, say from week to week, you double the floor space, you got an order that comes in that's going to be double what it was the previous week. You make chairs for the government or something. Oh, we need 200 chairs, not 100. Well, it could be a situation, it could be where you could double the floor space. You could double the number of machines, or you wouldn't even have to do that maybe, okay? That is to say you're not bumping up against some sort of fixed input. But as long as you're bumping up against some fixed input, when you want to ratchet up output, then you're operating what's in what we call the short run, okay? So it just depends. What's the short run? It just depends on your industry, kind of your manufacturing environment, if you will, okay? So first off, there's a concept here you want to make sure you understand. Is a production function is eventually concave. We call that a concave. You have this concave part. You may have the convex part initially, but you will have a concave part. It spills water. It doesn't hold water. It spills water. It's concave. And you have that because of the law of diminishing marginal product. That is just a phenomena of the short run. Now, we can take this curve here. Notice you got your variable input, workers here, and you got your output here, okay? Now this is your variable input. Also, you may have a fixed input, a fixed something there like floor space or number of machines or something like that you live with, right, in the short run, okay? And you got to rent those machines, so don't forget about that. But this is the variable input. This is what we can adjust on a day-to-day or week-to-week basis. So you got the variable input here, and you got the quantity of output here on my forefinger here, okay? So I'll do this for a reason. Imagine now if you could take this curve and turn it this way. That is to say, you could take this S-shaped curve here it doesn't really matter. But we'll stick with his. We'll do it with the S shape here in a little bit. But if you could take this curve and turn it, then this curve, I can almost trace it right there on my piece of paper, is going to look like this, isn't it? Okay, so in other words, I'm going to rotate it about the 45-degree line. That's the line y equals x, by the way. Okay, so that, here I had output and I had labor here. So now I'm going to have labor here and I'm going to have output here, okay? All right. All right, so what do I have here? Okay, I have here the beginnings of what's called a cost function. This right here is called a product function. Okay, that's a product function, right? It gives us the product for each variable input level. But if I do this, I get the inverse of it. Maybe from college algebra, you remember how to find the inverse function? If you got y and x, you switch those two variables, y and x, and then you solve for y again, okay? So I don't know if you remember that or not, but we switched these two. And that's what we did graphically when we did this. Now, this is the beginning of a cost curve, what we could call a variable cost curve, especially, okay, if we express labor in terms of the cost of labor. In other words, when I say variable cost, I need on the vertical axis a variable cost, a cost, okay? And, my workers, I'm going to use their numbers here. I forget what they use here. Let's see, I think it's, to illustrate this, they use $10 a worker, okay? So $10 a worker. If I took the number of workers and if I multiplied this by $10, so this is a labor hour, okay? I would get cost. I would get variable cost. So 5 workers, $50, okay? So, if I got $50 here somewhere, that's going to correspond to this point over here that gives me the output for $50 of labor. Does that make sense? Okay. So it's called a cost curve. This is called a variable cost curve because I express labor now, after I've switched to the X and Y axis, I express labor in terms of dollar cost. What's it cost for those workers? Okay, so this is called a variable cost curve. All right. Now, if I add to variable cost, the fixed cost. Now, what's the fixed cost? Fixed cost is the cost of renting the factory for the year or something. I could put that on a weekly or daily basis or even an hourly basis. If my unit of time here, if this is maybe 5 workers, okay, this is 5 worker hour or 5 labor hours, 5 hours of labor times $10 per hour. See what I'm doing there? So our unit of time here is an hour. So I get 5 hours of work, 5 people working for 1 hour. And I got to pay them $10 an hour. This is the cost for those 5 workers for 1 hour. Okay? So again, this is a lot of my cost in production, but it's not everything because I also have to rent the factory and the machines, and that is fixed. Okay, so you got fixed cost and you got variable cost. So you're renting that floor space. Okay, you can't tell the landlord, "Hey, we didn't use all of our floor space. We don't want to pay as much rent this week as we did last week." It doesn't work that way. Okay, you always have some fixed costs. So if you take the variable cost curve here, we can call this the TVC if you want, total variable cost curve, and we add fixed cost to it, you get a curve that looks like this. In other words, I shift up the total variable cost by the cost that's fixed. This is the total cost curve. Okay, so again, I got cost on the vertical axis. I got output on the horizontal axis, but I shifted up by the total fixed cost. A total fixed cost never changes in amount, regardless of what my output is on a day-to-day basis. If I break my rent down on a daily basis, 30 days in a month, if my rent is $3,000, I divide 3,000 by 30, what's that, 100? So $100 a day is my rent, okay, whatever it is, okay? That's just going to sit there regardless of what my output is. So I take that first, my total fixed cost. I'm going to take my total variable cost and add to it. That's this distance right here, TVC. I add TVC to TFC, I get total cost. Okay? That makes sense. So I'll get a curve that looks like this here. So I'm stepping you through the process here. First off, why does the total product curve look like this? Eventually, because of diminishing returns kicks in, but then because of this reflection and so forth, we can get a total cost curve. This is a total cost curve, TC, total cost. This is a total product curve on the left. Okay. Both of these have the same shape. Okay, this in that they're reflection, but this is concave because of diminishing marginal product. This one's convex because of increasing marginal cost. Increasing marginal cost. Decreasing marginal product. You see how those go together? You see how one implies the other? Okay. Decreasing marginal product means you're going to have increasing marginal cost. This is a phenomenon always in what? The short run or long run? Short run. You won't have this in the long run. You're not going to have this crowding out effect. See, this is due to crowding out. And you don't have crowding out in the long run. So it's in the fourth section of this chapter, we'll talk about production in the long run. But this is important for us. In the short run, you have this crowding out effect that causes these two things here. And this is important because there are a certain set of people in any organization that make the short run decisions, output decisions in the short run. That is, should we hire more workers to produce more chairs this week? The people who make those decisions are called managers. Okay? Managers make the day-to-day input decisions. The long run, like, hey, let's go out and rent some more machines or something, whatever it is that's the hardest to procure. Maybe it's floor space, got to build another factory. Manager's not going to say, hey, we're going to build another factory. You're going to have to go higher up in the food chain and talk to the owners there, so to speak. The ones who sit on the board or represent the owners, they make the decision, hey, we're going to go out and raise more capital, build a bigger plant. Okay? So, we're looking here today about managerial decisions, very real world, and this is a constraint that you're going to have. All right, now they work through one of these. This is graphical. Okay, I want you to see the graph first, and I'm going to add a little to this graph here in a minute that's also not in your book related to these curves. But they work through a numerical example for you here on page 274, okay? Now, the situation here, we can just look at this. This is a coffee shop, Caleb's Coffee Shop. Okay, I like that. My son-in-law's Caleb, so I think of him here. But so you got outputs of coffee per hour. Okay, that per hour implies, okay, you're operating in the short run. There's something here you can't go out and change on an hourly basis. So Caleb can produce 0, 1, 2, 3, all the way up to 10. As you'll see here, cups of coffee in an hour in his coffee shop. Okay, so there's a total cost. We'll come back to here for a minute, because total cost is the sum. Okay, I could put an equal here if I wanted to. It's the sum of two things. It's the sum of these two things. It's the sum of fixed cost and variable cost. Fixed cost, it's fixed. No matter how much his output level is, he's got to pay $3 an hour rent. Maybe it's the machinery, maybe it's the floor space, or maybe it's the sum of the two. $3 and that's it, okay? You can't do anything about that. However, when he makes cups of coffee, he incurs higher variable cost. Now, in this particular instance, it doesn't look to me like he has to hire additional workers to make more cups of coffee each hour, okay? But he does have to use more ingredients, more coffee, okay? So when we talk about variable input, variable cost are due not just to workers, okay? So I had to start somewhere here and say, hey, it's the number of workers that drives variable cost. But even here in our little furniture factory, it's also the wood, okay? If you double the number of chairs, you may have to have more workers, but you're also going to have more wood, right? And more varnish and all this. In this case, he's not increasing workers, but he's increasing ingredients. He's increasing the electricity he uses. In fact, as an economist, we realize there's lots of other costs you might overlook. Like, for instance, every hour he's working in his coffee shop is an hour he's giving up from his job he quit at the post office. Okay, so you have implicit cost here as well. Very important to consider for Caleb here in this enterprise. Not to go back and rehash all that, but there's, when we talk about variable costs for a minute, there's a lot that may go into these numbers here for each cup of coffee. Now I want you to see something here. A variable cost, first cup of coffee is 30 cents. The second cup is 80 cents. What are we experiencing here? We're experiencing increasing marginal costs. Let's go over here to the very last column and calculate what we call the marginal cost of each cup of coffee. Marginal means the one additional, okay, the additional unit. The first unit drove up our cost of operations by 30 cents. In other words, if we weren't making any coffee in an hour, you just paid the rent. And there's the rental cost here is that's a fixed cost. But when you move from the 0th cup of coffee to the first cup of coffee, you got to use some ingredients. So it's 30 cents, okay? You go from the first cup to the second cup in the next hour. Notice how these are staggered. They're staggered for a reason, because marginal cost is the cost of moving from here to here, okay? So you go from 1 cup to 2 cups. Notice here we can calculate our total cost. It's a change in the total cost, but the fixed cost isn't going to change, so it's also equal to the change in the variable cost. The variable cost goes up from 30 cents to 80 cents, as well as the fixed cost goes up by the same amount. So the marginal cost of the second cup of coffee is 50 cents. Does that make sense? Y'all see that? So notice something here. Right away, marginal cost goes up, it increases. The cost for an additional cup of coffee is increasing. So your author here, the great, and I'm not being facetious, he's really a great economist, Dr. Mankiw, is drawing this part of the cost curve, which is always going to be there. Now, and there may be some specialization. Maybe there's two people working in a coffee shop, and that first few cups, you stay over there and you do the grinder, I'll stay over here and I'll percolate it or whatever, however you make coffee. I use a Keurig, so my wife does the coffee brewing in our house. But at any rate, there's some specialization and increasing returns to a labor to be had here, perhaps, but I say perhaps, not necessarily, but this necessarily will happen. There is decreasing margin or diminishing marginal product. We're observing here diminishing marginal product causes increasing marginal cost. This curve is increasing at an increasing rate. So if you sketch or if you calculate marginal cost here, it's going to be an increasing number. Okay? So this is what you have here. Okay, so let's just back up here again. Make sure we understand this chart. You're going to have some problems where you'll have to fill this chart out. So you got total cost, is fixed cost, never changes, variable cost, okay. If it's, some labor or something involved, then you've got some diminishing marginal product here that's driving this up at an increasing rate. Now, I got average here for the next three columns. Okay, so what am I saying here? I'm saying that, let me grab a sheet of paper. As we noted just a moment ago with our diagram, I said here, total cost is the sum of these two things. Total cost is total variable cost plus total fixed cost. You add them graphically. That's called principle of superposition, by the way. But if I just write that for a moment, total cost is equal to total fixed cost plus total variable cost. That's what total cost is. That's what we're observing here with columns 2, 3, and 4. Here. Okay. Then I can take this equation here and simply go through and divide by Q, or output. You're seeing that I taught math for many years, so I'm a stickler. Write a new line. Okay, don't mess with that line. So if you got to go back, figure out how did we get here? Well, I don't do too much on one step. Okay, so I'm dividing through by Q. Everything, if this is true, that's got to be true. This is called average total cost. When you take a total and divide by a quantity, it's an average, right? If I say, what's the average age in this room? Okay, that's probably a pretty good one for what I'm going to talk about here in a little bit. Average age, we'd add up, we'd get a total and divide by the number of people in here. Divide by 20 or something. Okay? Same is true here. This is average fixed cost and average variable cost. So if this is true up here, this has got to be true down here. Average total cost equals average fixed cost plus average variable cost. So I just take these in the same order here and divide by quantity of output. I get averages. So first off, what I want you to be able to see is that how you calculate everything on this chart. Okay. Well, if we have time, we'll go back and work a problem. Read your book. You got to, especially this, you got to read this, think about it before you try any of the problems. Okay, see if you can kind of get the concepts down. Total cost is fixed plus variable. Average fixed cost plus average variable cost is average total cost. So I guess they got this in a little different area. This kind of order. So this kind of goes with this one here, right? And average fixed cost kind of goes with fixed cost. So forth. Okay, But at any rate, that's how you get your averages. Then your marginal. How do we get the marginal? Okay, it's pretty easy when you increment unit by unit. Marginal cost is just the additional cost for the additional unit. Okay, additional cost for the additional unit. Now let me just say something here a minute. What if this were a lot bigger coffee shop, and instead of measuring output by units or coffee cups, we did by units of 10 cups. So this were 10, this were 20, this would be 30 and so forth. What if it were units of 10 instead of each one? Okay, you can still calculate marginal cost, but you realize you're making a jump here from 0 to 10, not 0 to 1. And marginal cost is the cost of the additional, the next 1th cup of coffee. Okay, I'm being silly there. So how would you find that in that case? Well, again, it would be the change in total cost. So I could take the change in the total cost, okay, which I got a delta there. I'll go back, but I'm taking the change in these two numbers here and dividing by not one increment, an increment of 1 cup of coffee, but an increment of 10 cups of coffee. So if I take the change, which that's what delta means, I'm sorry, difference, capital D, 24 letters in the Greek alphabet, right? So that's a capital delta. Change by the quantity, change in the quantity, I'll get the marginal cost, or something very close to it for the first 10 cups of coffee, or for the next 10, or so forth. Kind of assuming the first and the second and third cup all will have basically the same marginal cost, okay? So marginal cost is the change in the total cost divided by the change in the quantity. Just here we have the luxury of being able to increment quantity of output by 1 unit instead of by 10, okay? So that's what we have here. Marginal cost. Okay. Change in total cost divided by the change in quantity. So if that's what these numbers are here. Now, I'll tell you what. Let's look at one of these. Like the 4th cup of coffee has a marginal cost of 90 cents. Do y'all see that? Again, how do we calculate that? The 3 cups cost $4.50. 4 cups cost $5.40. So the marginal cost for the 4th cup of coffee is the cost for the 4th cup, for 4 cups rather, which is total cost is $5.40, minus cost for 3 cups, which is $4.50. Okay? I hope y'all can read that. So that's the change in the total cost here. That's the numerator. It's the total cost for 4. I mean, I could have used some, but the change in quantity is 4 minus 3. Now, if we were incrementing by units of 10 here, then that would be 40 minus 30. And, you know, I might have the marginal cost of the 40th cup or the 39th cup. Be pretty close still, okay? So at any rate, when you do this calculation here, you get 90 cents, I think, right? You get 0.90 over 1, which is 0.90. Y'all get that? I mean, y'all see that? Okay. Marginal cost. Now, here is the total cost curve, and I want you to see where this is on this curve. You say, I don't see that anywhere. This is total cost, not marginal cost. This is output here, quantity. Well, guess what? If I zero in on the 4th cup, and I look at the additional cost associated with making the 4th cup. Y'all with me there? In other words, for 4 cups, recall it costs $5.40. For 3 cups, it cost $4.50. Y'all see that? Very important. What I'm about to show you is very important for what we'll be doing. So I'm going to blow that up. I'm going to draw the picture and blow it up, okay? So you'll see something. $5.40 and $4.50. So here we go, just real quick. Let me get a clean sheet of paper. That's what I'm saying right there. All right. When I wrote this thing just a moment ago, that marginal cost is the change in total cost divided by the change in output. The marginal cost of the fourth unit. The marginal cost is the change in making the fourth unit over the third unit divided by the change in output. That's the definition, or how we calculate in general marginal cost. Then I can see that on this graph. The change in total cost is this distance right here. When I wrote $5.40 minus $4.50, that is the rise. Okay? When I wrote 4 minus 3, that is the run. Okay? Make sense? So rise over run, does that sound familiar? That's called what? Slope. You know from algebra, the slope between 2 points on a curve, or just 2 points. The slope of the line that joins 2 points is called, or is the rise over the run. This is rise over run. This is to say, this line here, and we have a name for that line, by the way, they call that a secant line. Secant line. Whoops, I can't write. Secant comes from the Latin secare, which means to cut. So this is a line that cuts the curve in 2 points. Okay? The slope of the secant line, draw a little right triangle there if you want. Rise over run. The secant line is the hypotenuse, if you will, of that right triangle. The slope of that is the marginal cost of this unit right here. Okay? So, can you imagine with me, I could find the marginal cost of each cup of coffee here by constructing a polygon here, okay, and finding the slope of each segment of that polygon. So I could likewise find the marginal cost of the 5th cup and the 6th cup and so forth. So instead of having a smooth curve, I got this little polygon, and I can find the slope of each section. Each one, they're turning this way, and they're getting steeper and steeper. Okay? Does that make sense? I'm giving you some concepts today that'll help you in your reading. Now, these are units of 1 here. I'm incrementing output by 1. But if this were a big coffee factory here, I might have these in units of 1,000. So I've backed off here. And if I want to find the marginal cost of the 400th cup of coffee, and these are in units of 100, then I got to move to the left and look at the total cost of the 399th, right? Does that make sense? So if I back off, if I'm producing lots of output, and my decision on a day-to-day basis is to change from hundreds of cups of coffee instead of 1 unit per hour, or hundreds of cups of coffee per hour. In other words, I have my big operation, then my total cost curve is going to look the same. If I want to find the marginal cost of the 400th cup of coffee, I'll do the same thing, but notice here, because of scaling, the 399th is like right here, right? You get my point? And so, yeah, I can do this. I mean, that's a small, the rise is really small, okay? And so is the run, because I'm looking at big quantities. But guess what? The slope of that secant line that cuts the curve in 2 points, like this, is basically the same as the slope of a curve that touches, or a line that touches the curve. Instead of cuts the curve, it touches the curve. Okay? I know I'm getting a little abstract here today. They call this a tangent line. This is called a secant line. So this doesn't touch the curve. If I just say, well, those two are so close to each other, I can't tell the difference. Even with my microscope, man, it's bugging my eyes out. So let's just take this point and let's just brush it with a line. Instead of connecting 2 points and all that, let's just draw the tangent line. And when I draw the tangent line, I'll take the slope of that. Guess what? The tangent line will give me the marginal cost, real close anyway, of the 400th cup of coffee. Because, you know, that's about this, it's going to have the same slope as the secant line when I'm looking at big quantity levels here. Because I got to compress that horizontally. Does that make sense?
So,
yes. And I'm getting a little abstract here today.
I guess I'm just wondering, like, how would we then calculate the slope of the tangent?
Oh, okay. Take a
or
course.
Does that get into more technical stuff that we're not actually doing?
Well, take a course in differential calculus.
Okay.
Okay? So you'll see how all this fits together. So I would love to. Used to teach calculus for years and all that, but alas, I'm doing more interesting things teaching economics. Because for me, math is a tool. It's not the end all. But yes, when they talk about differential calculus, you're finding slopes of curves. So how does you find the slope of a curve? Well, you find the slope of the tangent to the curve. Okay? So when we get into limits and so forth, the limit of the slope of the secant approaches the slope of the tangent when you back off like this, like we've done here. Okay? And I'll just leave it kind of at that. All right, so it's in the realm, because you raise a profound question. How do I find the slope of a tangent line when I have only 1 point that defines the tangent, right? Secant has 2 points. There's your thing. I mean, how do I know exactly? I got a little play in the wheel here, right? You probably know. Well, there's a way to find the slope of this line that touches a curve in 1 point, okay? There's a way to do that mathematically, where you don't have to have 2 points to determine the slope. You have only 1 point in the curve itself. Okay, all right. So now if we go back here just a second, what I want us to see is that here, those tangent lines are rocking up this way as we produce more and more output. Okay, now if we take the more general approach here, I want you to just see this for a minute. This total product curve, as we sketched it a while ago, is this backwards S-shaped kind of thing. Let me just sketch it again. Okay. Total product curves look like this. Okay. Those tangent lines kind of are steep here, low levels of output. They get steeper, and then they kind of start to trail off over here. Okay. So marginal cost is high initially. It gets a maximum right about here, and then it levels off. Does that make sense? Okay. When we look at the more general total product curve, where you got output in terms of labor or whatever, total product kind of looks like. And total cost, how about total cost curve? Well, you get the marginal cost curve, okay, which this is part of the total cost curve, but remember it goes down like this. So remember you got to reflect this. So the total cost curve, okay, just make sure we know the difference in these. Again, total cost curve is a little bit more than what he has pictured here. But I'm going to kind of expand on this. Total cost curve looks like this. At any rate, all right, for low levels of output, marginal cost is, well, it's kind of a steep, but it's going to get smaller here. Marginal cost is high, then it goes down, then it starts to go back up again. Okay? Marginal cost goes down and then goes back up again. But in the short run, you always have this part of the total cost curve. You always have that part. So that's what he's drawing here. And so what we know in the examples he'll do in your book is that marginal cost will always increase. But it's important to note that they decrease as well in the more general context. Okay? So we got output here, and you got cost here with the total cost curve. If I were to sketch the marginal cost curve, it's steep for low levels of output. Then it goes down and then goes back up. It's what we call a U-shaped curve. And I'm just going to put this here for a second. This is the total cost. But the marginal cost for the same levels of output, dollars here is not total cost, but it's marginal cost. We're going to see that it has a minimum right here at this level. Maybe this is 500 cups of coffee, whatever it is. Marginal cost looks like this. Okay? But again, Mankiw, which I know why he's taken the efficient route, the most easy way to learn this initially, because these are new concepts. He focuses on this part here, which is always going to happen. You have increasing marginal cost because, we had diminishing marginal product. We're seeing increasing marginal cost here. That's the marginal cost curve, and this is the total cost curve, okay? All right, and we see that in this example here. Right away, it's kicking off. These are getting bigger. Your first exercise or two will be to fill out this chart. And then you're going to want to think about the marginal cost curve, what it looks like. There's more. There's the average cost curve. Think about average for a second. Average, there's a kind of a formula like this for average, but you take the deltas off. Average cost is total cost over quantity. A while ago I talked about average, and I said you could find average cost by taking the total. Let's think about that just a second. All right? Again, today's concepts, okay? Average total cost is total cost over quantity. So I don't have my deltas here that define marginal cost. It's not the change in the total cost over the change in quantity. No, it's just total cost over total quantity. But that's how you find the average of anything, right? What's the average age in here? What's the average, if we've measured wealth by the amount of money you have in your wallet or on your person? Cash, currency. What's the average currency? Well, if we threw all of it in a plate and divided by 20, say there's 20 people here, we'd get the average. Okay, that's what this would be. Average. Is there a way to picture that on this total cost curve? Remember the total cost curve? Mankiw draws part of it, but let's draw the whole thing here. We had this a while ago. I sketched it. Can I find it? After we did all the reflection, I want to make sure you see where I did it. All right. Well, total cost curve is here. We did it down here. It's also in your book. But here we go. Here's the total cost curve. It looks like this. Total cost. As Mankiw does it there, okay? We'll just stick with him for a minute, Mankiw. Okay, so at any rate, what we have here is cost, and you got quantity here. Total cost is that. Remember, it has fixed cost and variable cost. Now let's say, what's the average total cost of some level of output? In your book, on this example, where they do this computation here, also for 3 cups of coffee, they get average total cost is $1.50. Y'all see that? 3 cups of coffee, average total cost is $1.50. How did they get that? They took the total cost and divided by the quantity. Take this number and divide by this, you get that. Average total cost. Likewise get average variable cost and so forth the same way. So it's the total cost divided by the output. $4.50 over 3 cups of coffee. $4.50 over 3 cups of coffee. Now graphically, I'm saying here that the average total cost of the third cup is $4.50 over 3 cups. It's the total cost of 3 cups divided by the quantity. Guess what that is? That's the slope of a line that extends from the origin to that point on the total cost curve. Okay? In other words, I start here, and the rise is the total cost. It's not a secant line. This is a line that joins the origin with a point on the total cost curve. So it's this distance divided by this distance. Again, rise over run, but for a different line, so it's a different value here. Okay? So, the way I've got it drawn here, I could find the average total cost for other cups of coffee, right? Say, what's the average total cost for 2 cups? I'd come over here to 2, and I'd look at this point here. It's a little harder to see. I'm going to put it right here. And I'd join these 2. That would be for 2. And for 1, here's 1. I find the slope of that line. How about for 4 cups of coffee? I join the origin with this cup, with this point. Now here's what I want you to see. I brought my colored paper for a reason today. Those slopes go down as I increase output, then they go back up. Okay? As I increase output, average total cost goes down and then goes back up. It also is a U-shaped curve. Like the marginal cost curve is U-shaped. Okay, it looks to me like perhaps at this level right here, I'll get the minimum of the average total cost curve. Let's see here. Average total cost. I want you to see this row or this column of numbers here. Now marginal cost kept going up, right? The way he draws the total cost curve, only part of the usually the total cost, because he's omitting the first stage of production. But that's okay. Marginal cost always increases. But notice something here about average, okay? Total cost. Marginal cost increases, but average total cost, look at these numbers. They go down. Look here, they're going back up. You see that? I smudged it, didn't I? Leave it to me. It goes down and goes back up. Here we do see the U shape. In fact, on this curve here, you're going to see that. It goes down and then goes back up. Average total cost curve is a U-shaped curve. Marginal cost will be too if you draw this more general, but again, for his example in this book, he really focuses on increasing marginal cost is inevitable. So these numbers increase and these numbers will go down and go back up. Also with the average variable cost, these as well, if he included enough of them, I haven't. Average variable cost, well here it just goes up, but again if we had the first part of the production it would go down and then go back up. It also is a U-shaped curve. It's just we don't have enough of the curve here to see it. But you do here for the average total cost curve. Okay. All right, so where are we going with this? Okay, we're almost there. We're not completely there. But so this is going to take a little more time here. But this is the crescendo here. We're going to talk about these curves. Average total cost is above the average variable cost curve. They're always U-shaped. The marginal cost curve is a U-shaped curve. Here's your average fixed cost. You're averaging over larger numbers, larger output values. But the marginal cost curve will always go through the minimum of the average cost curves. That we have yet to justify. We will next time. So spend some time with this, okay? What we call the short run cost curves. These are short run, not long run, but short run. Okay, any question? Looks like I'm out of time.